guys, welcome to Learn Chemistry. Hello guys, welcome to Learn Chemistry. Today we are going to be learning about uh, chemistry and some topics. This is a much for science students. First question says that addition of water to calcium carbide results to the correct answer is a chemical change. A chemical change. Now, a chemical change is that type of change that is irreversible. That is what irreversible, and new substances are formed. Physical change is that type of change in which no new substance is formed, and it is easily reversible. So calcium carbide in water is going to result to a chemical change, which products will be acetylene gas, which is C2H2, and calcium hydroxide. Number one to note is that under chemical change, no new substances are formed. Number one, change is irreversible by simple physical means, and it is a chemical reaction. Those are three things we need to know about chemical change. Okay, new substances are formed. Change is irreversible by simple physical means, and also it is a chemical reaction. Number two says that a physical property is A, rusting, B, precipitation, C, neutralization, D, melting point. D, melting point is correct. But firstly, what is a physical property? A physical property is uh, a property that can be observed or measured without changing the chemical nature of the substance. A very good example is melting point or boiling point. They are example of physical property. All right. Quickly, after that, we have number three. An example of physical change is D, dissolution of salt in water. Now, why is it D? Now, dissolution of salt in water by evaporation to dryness will make us recover our salt back. So, meaning that after dissolving salt in water, we can evaporate the water and get our salt back. So, it is a physical change. A physical change is reversible. It is reversible. All right. Another example is freezing of ice cream and so on and so forth. So, if it is easily reversible, is a physical change. Rusting of iron is not a physical change, it is a chemical change. Souring of milk is also a chemical change, and burning of food also is a chemical change. But the solution of salt in water will give us a physical change. All right. Okay. Number four, a mixture of potassium chloride and copper uh, copper tricarbonate 4 is best separated by A, dissolution followed by crystallization, B, dissolution followed by filtration, C, dissolution followed by sublimation, and D, dissolution followed by evaporation. C is uh, dissolution followed by sublimation, and D, dissolution followed by evaporation. Our correct answer is B, dissolution followed by filtration. So, because potassium chloride is soluble in water, Therefore, we can dissolve potassium chloride in water. Then, the crystals of our answer is B, dissolution followed by filtration. We have to first dissolve our potassium chloride, which is soluble in water. Then we're going to get crystals of copper tricarbonate 4, which can be easily filtrated, and it becomes the residue. All right, while we filtrate the water, uh, which is the potassium chloride going outside with the water, and we can do that. We can get a mixture. We can get our potassium chloride by evaporation to dryness after we have filtrated the copper tricarbonate 4 from the solution of potassium chloride. All right. Then next one is a compound that absorbs a compound that absorbs moisture from the atmosphere and eventually forms a solution is said to be deliquescent. Deliquescent. Now, a fluorescent compound loses water of crystallization to the air. Example is sodium tricarbonate for decahydrate. So if they're having hydrate at the back, like 10H2O, 5H2O, 7H2O at the back of the compound, then we say it's an efflorescent compound. Now let's talk about hygroscopic compounds. They absorb moisture but does not form a solution. Example is H2SO4, that's sulfuric acid, and another one is quicklime, calcium oxide. Quicklime is an example of hygroscopic uh, substance. They don't form solution, but they can absorb moisture from the atmosphere. And the next option says anhydrous. Anhydrous compounds, they contain no water. They don't contain water of they don't contain water of, at all. So example is anhydrous calcium chloride. So anytime you hear anhydrous, anhydrous does not contain water, be it moisture or water of crystallization, they are always dry. So they are called anhydrous. That's the opposite of hydrated. Hydrated and anhydrous. All right. Then lastly, we have to talk about the deliquescent, which absorbs moisture and forms a solution. So our correct option here is deliquescent. Deliquescent, they absorb moisture from the atmosphere and also forms a solution. All right, example is calcium chloride, sodium hydroxide, and potassium hydroxide. Okay, now our next question says that which of the following metallic oxide is amphoteric? Which of the following metallic oxide is amphoteric? Our option there is lead oxide, copper oxide, magnesium oxide, and iron 3 oxide. Okay, now the correct option is lead oxide. Lead oxides react with acid and bases. Okay, we have amphoteric oxides like lead oxide, aluminum oxide, we have zinc oxide, we have tin oxide like tin 4 oxide. Okay, we have to be very careful when we are picking this kind of answer, okay, because amphoteric means that they can react with both acid and base. So if they can react with both acid and base, they are they are known as amphoteric oxides or amphoteric metallic oxide. All right, amphoteric metallic oxide. All right, now copper oxide is not the answer because copper oxide is a basic oxide. All right, it's a basic oxide. Also we have magnesium oxide, which is strongly a basic oxide as well, and we have iron 2 oxide, also a basic oxide. All right, so our correct answer is lead oxide because it can react with both acid and base. All right, so they are known as amphoteric oxide. They are known as amphoteric oxide. Now, quickly, number 7 says that metal conducts an electric current due to the presence of correct answer is B, free mobile electrons. Free mobile electrons. Now, that is mainly the reason metals can conduct electricity. They have free mobile electrons. Okay. Now, number 8 says that a mixture of two immiscible liquids can be separated by A. Separatory funnel, B. Distillation, C. Filtration, D. Chromatography. Now, separatory funnel is used to separate immiscible liquids. All right. Example of immiscible liquids are oil and water, kerosene and water. So they don't mix. So they are known as immiscible liquids. So it is used to separate liquids based on their difference in density. Difference in density. So that is what separating funnel is used to do for to separate liquids based on their difference in density. All right. So distillation is used for miscible liquids with different boiling points. So that's what distillation is used for miscible liquids. But we are talking about immiscible liquids here. And we have filtration, which is used for liquid mixtures, and we have chromatography for separating dissolved substances, dyes, colors, etc. According to their migration. So we call that chromatography. So the correct answer here is separatory funnels. separatory funnel. Is used to separate immiscible liquids, liquids that do not mix. Now, our next question is number 9. A substance commonly used for drying ammonia gas is a substance commonly used for drying ammonia gas is A. Concentrated H2SO4, B. Magnesium trioxynitrate 5, C. Quicklime, and D. Anhydrous calcium chloride. All right. Now, before that, let's talk about uh, anhydrous calcium chloride, which is our answer. Now, anhydrous calcium chloride, all right, anhydrous calcium chloride does not react with ammonia. Firstly, the ammonia gas is a basic gas, all right. So, if we are going to use H2SO4, H2SO4 is acidic, so it would most likely react with ammonia. And magnesium trioxynitrate 5 cannot be used as well for it does not use, we don't even use magnesium uh, trioxynitrate 5 for drying gases at all, so that is out of the option. But we can use calcium oxide, but this is less commonly used. All right, so calcium oxide can absorb moisture easily, so it is less commonly used. So the most commonly used here is anhydrous calcium chloride. All right, now acidic gases like hydrochloric acid, SO2 sulfur oxide are dried with concentrated H2SO4. All right, acidic gases like HCl, SO2 are dried with concentrated H2SO4 because they are acidic gases. So we use acidic, sorry, we use acidic gases also to what, to to dry acidic gases, but we use basic gases, all right, to dry basic gases. Now, basic gases like ammonia can be dried with anhydrous calcium chloride. Lastly, mean our answer is D, which is correct. Now, lastly, number 10, which of the following oxides would produce an aqueous solution having a pH less than 7? Now, I want us to drop our answer in the comment section. Drop your answer in the comment section, and please do like, share, and follow. And also, you can subscribe on our YouTube channel, Learn Chem. It is there, and we are taking proper and full classes on our YouTube channel. Thank you and well done.